All right, line L1, we're going to take a look at learning task 3, which is going to describe specialty bonding applications. Once again, something that may not apply to the work that you do on a day-to-day basis does apply to a lot of electrical companies here in the Fraser Valley. We do still have a fairly large agricultural aspect of it. And it is going to be a requirement of our ITA that we cover these things, particularly where it becomes dangerous to not know about these, is to not know about some of the ground control devices that we're going to have inside of here. Most common one that you're going to find in the Fraser Valley, actually throughout the province, is going to be the system that's going to be called the gatekeeper. And the gatekeeper system is going to be a specialty grounding application. It's a tool that we're actually allowed to place into the ground path that is going to monitor, disconnect, and reconnect it based upon what is referred to as straight earth currents. If you don't know what one of these is, and you run into one of these that's at a main service, don't touch it. Okay, you need to know what it is because it changes the way that the grounding and the bonding is done, and it can cause some massive problems for the livestock themselves, inhumane problems, electric shock, etc., if these things are not monitored and installed properly. Okay, so let's talk about what straight earth is. They refer to this as straight earth current. These are really going to be induced voltages that are going to be placed in there. Now, animals do feel these things much more than humans. You and I can go and touch stuff that has got straight earth potential off of it, and we won't feel anything. But for cattle, that's a big one here, the livestock, when they stick their nose into a metal basin, that's going to be automatically filled with water, that they're watering troughs, and there's electric charge off that, they feel it. Tends to make them not want to drink. It's not healthy to go around not wanting to drink or to be stressed out every time that you need to take a drink. You're stressing because you got to take a drink and you're going to get shocked and then you get the shock, etc. These circulating currents that are going to happen inside of here are induced by a couple different things. One of them is going to be like electromagnetic induction, ballast fed lightings. We have a lot also that comes off of triboelectric effect, rubbing effects, where we're moving air. There's a lot of air movement that is used for pneumatics to operate gates, to go and have vacuum lines for milking, things like that. And then last of all, they could be off of actual electrical faults. But they're going to be tiny, so small that we won't necessarily catch them with a GFCI. We do have, under the Canadian Electrical Code, that we have to go and make sure that we account for these. Under 10700E. We're going to go down there a second. Oops, 10700s. Just grab that one. And there we are. Equipotential bonding of non-electrical equipments. This talks about the following parts of non-electrical equipment shall be made equipotential. That means at the same potential or bond together with the non-current carrying conductive parts of electrical equipment. In other words, we have to bond them to our bonded electrical system. The stuff that we've talked about before, gas and water and sewer pipes, conductive materials under floors, conductive metal parts of structures that house livestock. Note that they say metal parts. This actually does include not just, the stanchions, the water troughs, anything like that, but it also includes the sheet metal on the buildings themselves. That does have to get bonded down as well. So anything that's metallic inside of a structure that livestock can access. If they can't access it, we don't have to worry about it. But if the livestock can access it, we do have to go and worry about it. We are allowed to go and place some specialty components in there that are going to monitor and react. They've got a way of mitigating these things. We'll just go up to 10116 over here. Sub-rule 2 says that where necessary, devices to control the effects of stray earth current shall be permitted to be connected in series with the grounding conductor. Note that the sub-rule above it, the installation of the ground conductor, that's the one that goes between the neutral and the actual ground itself. Note that above it, it says the ground conductor has to be electrically continuous. We're not usually allowed to break them up, but this is a specialty place where we are allowed to place them in. Follow these things. If you're going to place one of these in, talk to the inspectors in there, Technical Safety BC, your civic inspectors, for some of the cities or outlying areas around them. All of those are going to want to know that one of these has been placed in there, and that's a certified unit. They are certified. They are designed for that. They should be placed in there. Okay, talking about the subfees that go between buildings, there is an old school method of, once again, distributing electricity. This was done off of previous code books. 2018 code book, we changed the way that this could be done. We were no longer allowed to go and do this, but you will see this inside of other places where you are going to go and have your main service coming in. So there's going to be your transformer that's going to be out of the pole. That transformer is going to go and feed to the actual lines themselves over there. So there's my 3 lines being fed in there. 12240, we feed that down into this panel over here. Inside of this panel, I ground down my neutral. I bond that neutral as well down inside of there. And then I am going to go and, feed loads inside of that building. And then I'm going to go and feed overhead to another area. Overhead, subfeeds are very common between buildings because it's easier than trenching up, particularly when you're crossing like driveways or things like that. So we see that over here we got 2 lines and a neutral get carried up, and we're only carrying across 3 conductors over here. 2 lines and a neutral. You should be familiar with that drawing convention where they show 2 short lines and then 1 long line. The long line is usually going to be your neutral, is what it's indicative of. But we're carrying 3 lines over top. We would do that through what we refer to as a neutral supported cable, or commonly a triplex is what we would say. Over here, we see that that comes down into here, and then it is going to get tied down in. I see that I've got my neutral once again bonded down. See how this was bonded? This was bonded over here as well. And then I'm reestablishing a ground point over here. This used to be allowed. It is no longer allowed. However, once you find an installation like this, if this installation was put in to the old code, you don't have to change it. It's allowed to exist. But if you are upgrading, you would have to change it to a proper installation that would go and have only a single point that is going to be grounded. This one over here, my actual ground conductor over there. Once again, the same transformer feeds into this thing. I feed down into here, and then I see that where I'm feeding out, I'm actually going to feed 4 wires up my mast over here. I'm going to have that bonding conductor that's going to go up that mast there as well, and I'm going to carry it over. This is going to require now for me to go and have 4 conductors. We're going to refer to this usually as being a quadplex. That's going to be carried over there. So I'm going to carry over my line 1, my line 2, and my neutral, all as insulated conductors. My bonding conductor would be the one that I would go and use as that, what we used to refer to as the neutral support, but we'll refer to that now as the messenger cable that's going to go across. And then I carry that down. I add the weatherhead, have to carry that bonding conductor all the way down to the bottom, as well as I need to go and have my neutral and my 2 lines that are going to be brought in there. And then I disconnect that bond strap that's going to be downstream. Once again, if I didn't disconnect that bond strap, if that was in there, then what I could have is I could have my current that is going to be flowing from here. Oh, I don't know, grab a different color marker. We'll use a red here. We have current that would be flowing through out of my breakers, going out to a load, traveling through that load, coming back to my neutral, and then it's going to travel through the neutral, and some of it will travel up the neutral, and some of it would travel down here and travel over top of that bond. That would be considered to be objectionable current flow, so we remove that, which means that all of that return current goes back up our neutral. This is the only proper way for you to do an overhead service. You are not allowed to go and reground at another building, particularly where this became apparent, and then they just changed it and said, well, why don't we make all the buildings like that? Because it makes more sense. It became apparent inside some of your livestock buildings once again. The book refers to as the liquid waste of cattle tends to be highly corrosive. Lots of salts, lots of ammonia. Because this is all on the ground, it's all leaching through the concrete, and we're ending up with massive corrosion on some of our components. So in this case over here, where I had a ground in there, the cable itself or the ground electrode can get damaged or heavily corroded. And what happens then is that any fault current would no longer be able to go and travel back through it, right? Where we would no longer establish that ground. If we take a look at what's happening inside of here, we would see that any sort of a stray earth current itself could go and potentially travel through, here's my bonded conductor over here, so I can go and have neutral current that would normally go back to just along the neutral. Now that current can go and travel through here, travel through these, and then travel through the earth itself. You complete your path to ground through the livestock. This is inhumane. This is illegal. You're not allowed to go and have it. Also, these buildings themselves would not be allowed to go and have aluminum inside of them. The Section 22 of the code explicitly goes and prohibits the use of aluminum conductors inside of any building that is going to go and house livestock. By the way, livestock is not related to just cattle alone. Livestock is any live animal. So that could be horses, it can be cattle, it can be chickens, turkeys, pigs, ducks, rabbits. There's all sorts of different things that get farmed here in the Fraser Valley. All of those things do need to go and follow these rules. So particularly this one here, that's why they prohibited this. For buildings that house livestock, you were not allowed to go and ground it. You had to carry it over. These days, all buildings need to go and have it all carried over. You're going overhead sub-distribution, carry the bond up, carry it over with everything else. Obviously, if you were going underground with cable, this would already happen because underground cable, ACWs and techs do have that bond conductor that would be inside of them, inherently in there. Okay, that is the end of Learning Test 3.